All right, hello everyone. Happy Friday. I hope everyone is doing well. As I told you guys before, I'm out today, but if you're watching this on Zoom and you're at home, please make sure to log on to Zoom. That's how the sub will be taking attendance. So today is all about surface area of cones and spheres. So let's take a look at a cone diagram. If we look at the 3D figure of a cone, it looks like we see here, where we have the slant height, the height of the cone, the radius, and in purple, the circumference of the base. If I were to take apart my cone and make it look like a 2D figure, it would look like this. So you can see that the circumference is also the same part that you see right here. So this part right here is the circumference of your base, which is your circle, and your slant height is still there. So let's go ahead and talk about it. The lateral area of a cone, what we're going to do is we're going to break our lateral area into infinitely many pieces so that each piece is a triangle. So let's take a look at this. So if I were to draw this in, we have a triangle here, we have a triangle here, we could have another little triangle here, and we could keep going. So this is technically the area of a sector is what's going to help me determine this. So we know that our area of a sector formula is going to be the sum of my triangle areas. So that's going to be 1/2 times your base 1 times your height plus 1/2 base 2 times your height plus 1/2 base 3 times their height, and so on. We have infinitely many triangles. But the height of these triangles is the same thing as our slant height of the cone. So in all of these, I can say that my height is the slant height. So we can now redo our formula, and we can say that we have 1/2 base 1 times slant height plus 1/2 base 2 times slant height plus 1/2 base 3 times slant height, and so on. So let's go ahead and factor out a 1/2 and a slant height because they all include those. So we have 1/2, we have our slant height, and then we have all these bases added together. What do all those bases added together technically create? Well, if you think about it, all those bases added together is technically the circumference of my cone. So we know that our circumference formula is, so let's add this on, 1/2 times slant height times our circumference formula is 2 pi r. Okay, well, those 1/2 and the 2 cancel, so my lateral area formula for a cone is pi times r times s, which is my slant height. All right, now my total surface area is going to be my lateral area of my cone, so the equation from above, plus the base of my cone, which is a circle. So total surface area will be pi r slant height plus 2 pi r. So go ahead, take a moment, make sure that you have that down, and then we'll go ahead and get started on our examples. So for number 1, it's telling us to find the exact lateral area of a cone if its height is 5 centimeters and it has a radius of 12 centimeters. So let's help ourselves by drawing a diagram. So we have a cone that has a circle base. Our circle base will look like this. Okay, and it told us that we have a height of 5 centimeters. Let's draw that in. And we know height is perpendicular. And we have a radius of 12 centimeters. My lateral area formula is going to be of a cone. So lateral area of a cone is pi times r times slant height. Well, we know our radius here, which is great. Our radius is 12. We need to figure out our slant height. The slant height is always right here. Well, can we figure out what that slant height is? Yeah, it's a triple. We have a 5, 12, 13 triple, meaning that my slant height here will be 13. So the area for my lateral area of a cone is pi times my radius of 12 times 13. So take a moment and calculate it. Okay, and we should get that our lateral area of a cone is 156 pi centimeters squared. If you have any questions on this part, please pause the video and make a note to ask me tomorrow. Now go ahead and take a look at example number 2, and what I want you to do is write out your plan. It's asking for the exact surface area for the figure below. Remember, when you're thinking surface area, you're thinking anything in this shape that you could paint. So you wouldn't take those cones off and paint the insides of those circles. So our plan here should be the lateral area of cone 1. So we'll call this guy here cone 1 plus the lateral area of my cylinder plus the lateral area of cone 2. Because lateral area is not those circles that are included there. So your blank is going to be 15 feet. At this point, I would like you to pause this recording and try and solve this problem on your own. Okay, so hopefully you were able to figure it out on your own. So let's go ahead in cone 1. Let's figure out our lateral area. So lateral area of a cone is pi times your radius times your slant height. Well, we have our radius, which is 8. We have our slant height, which is 10. And pi is pi. So my lateral area for cone 1 is 80 pi. Now let's figure out what's my lateral area for my cylinder. Well, we know that the lateral area formula for a cylinder is your rectangle that it creates. So we have a height of 12, and the width is always going to be my circumference. So we know the radius is 8, so 2 pi times 8. So my lateral area for my cylinder is base times height, which is 12 times 16 pi, which gives me 192 pi. Next, we have to find the area or lateral area of cone 2, which is pi times radius times slant height. Well, we weren't given our slant height here, but we know that the radius stays the same, so 18 feet. We know that from here to here it's 15. While thinking, okay, so we know here we have our radius of 8. We have to figure out our slant height times pi. Again, we have that triple that's formed in 8, 15, 17 triple. Therefore, my hypotenuse and my slant height is 17. When I multiply that together, I get 136 pi. Therefore, my total surface area that I could paint here is 80 pi plus 192 pi plus 136 pi. When we add it all together, we should get 408 pi feet squared. Okay? What I want you to do now is watch the YouTube video that I have linked in your notes. So watch the video. When you're done watching the video, so pause it, pause our recording, watch the video linked. And now we're going to talk about our surface area formulas for sphere. Well, based on what you learned, we should see that we have our radius of our sphere here, and that our total surface area formula for a sphere is 4 pi r squared. Whereas total surface area for a hemisphere is half your sphere, will be 4 pi r squared, your total surface area of a sphere, divided by 2 because it's half, plus pi r squared because your base is the circle. So this ends up being 3 pi r squared. So pause the video if you need to. Okay, let's take a look at example number 3. A hemisphere is stacked on a cone. Find the exact total surface area of the figure below. All right, write your plan. Well, I need the surface area, the lateral area of my sphere plus the lateral area of my cone. So my blank here is 12. So take a moment, try and solve it. Since this is also a radius, we can say this is 3 centimeters. Therefore, the height of my cone, 12 minus 3, is 9. So lateral area of a hemisphere is 2 pi r squared, because remember, we're not adding on that circle base. So we have 2, we have our pi, and we know our radius is 3. So therefore, we get the lateral area of our sphere is 18 pi. Now we know that the lateral area of a cone is pi times r times our slant height. We know that our radius is 3. We now need to figure out what's our slant height. Lucky for us, this makes a right triangle. So we can solve for our slant height. So 3 squared plus 9 squared equals my slant height squared. 9 plus 81 equals slant height squared. 90 equals slant height squared. When we square root both sides, we get our slant height is 3 root 10. When we multiply that out, we get 9 root 10 pi. And we can't add things that have a square root and not a square root. So our total surface area is 18 pi plus 9 root 10 pi centimeters squared. Again, if you had any questions throughout, please make sure to write your questions down and ask me on Monday. If not, you are free to get started on homework number